So the next sequential logic circuit, that's the D flip-flop. So basically D flip-flop is another modification of SR flip-flop um, with the structure and the characteristic table as shown below. So from the characteristic table, we can see that the output of the D flip-flop remain during the subsequence of clock pulses. The output change only when the value of D change. Okay, so we can see that the structure of the D flip-flop basically have the two parts. With the first part, this is the SR flip-flop, and the second part, that the way we add a um, NOT gate to the input of the SR flip-flop. Okay, so we can see that the D at the input fed directly to the input S, and another branch is gonna go through a NOT gate, and the output of the NOT gate gonna be fed into the input R. The output of the D flip-flop also have the two outputs. That's a Q and Q complement. Okay, so let's look at the characteristic table. We have the when D equals 0, the QT plus 1 equals 0. D equal to 1 and Qt equal to 1. Okay, so you can see that the output Qt the same with the value of the input D. In fact, the flip-flop is the fundamental circuit of computer memory. Okay, so because of the we can see that the value of the Qt plus 1 always the same with the value of the input D. Okay, so you can think this one like a memory cell when the input D at the information we want to store in the computer memory, and later on you're going to read it out by using the output Qt plus 1. Okay, so the output always the same with the input. Okay, if D equals 0, Qt equals 0, D equals 1, Qt equals 1. So you can see that when we store the bit 0 or bit 1, later on you can read the bit 0 or bit 1 out. Okay, so that's the way we store the memory in computer. So in order to construct a larger memory, we just concatenate and combine multiple D flip-flop together, so we can construct more memory cell, and we can store more information. So in order to characterize the behavior of sequential circuit, we can use the characteristic tables, or we also can use the finite state machine. Okay, so basically the finite state machine that consists of a set of nodes that hold the state of the machine or the circuit, and a set of edge or arcs that connect the node together or the state together. There are two main types of the state machine, that the Moore and Murray machine. Okay, that basically they are equivalent. The only difference is that the way they express the output of the machine. Specifically, the Moore machine places the output on each of the nodes, while the Murray machine present the output on the transition or the edge connecting between the nodes. So more detail of the Moore and Murray state machine can be found in the textbook, and we're gonna skip in the lecture.